do we really do out there in the calculation of thermal growth? If we're going to do thermal growth calculation, we have to know the coefficient of expansion. And that means all different types of metals grow at different rates.
Exactly.
So within the formula, we need to know the change in temperature between the operating and the non-operating, or what we call hot and ambient temperatures. And then we have to take into consideration the height, and that is from the base to the center line of the shaft. But go out and get a reliable source of coefficient of expansion. And then we would actually put that into the formula there, and then we could do an average temperature. And Dana, if you would, talk to us a little bit about where we would get those readings from.
Usually on the machine set, you would get those readings from the base to the center line of the shaft. And at a minimum of 4 readings. I don't care how small the machine. If it's a larger machine, you may get more, because you want a good average before you start calculating the difference in hot running temperatures versus sitting there static and having a chance to cool off, so you have good
Where would
averages.
we get, like, say, the ambient temperature? I mean, we're going to take temperatures of the motor and get an average, but we've got to have some ambient temperatures too, right?
You need to catch that machine on a day that it's been down for a while and see what that machine changes to.
Or what if we didn't have that option? Could we not, say, go in and check the surrounding, the purlings, some of the material around?
You could absolutely do that.
And that would give us an ambient. So,
Yes.
when we get to that calculation,
Yes.
that would really be our cold temperature. Because really, thermal growth is based on a differential.
Yep.
So talk about the bases just a little more, Dina. When we say from center line of shaft down to the base.
From the base, right where the feet sit on the base, up to the center line of that shaft is where we're going to take those temperatures.
Okay.
Down to the rigid base in most cases. Down
Okay.
to the rigid base in most cases.
Okay. All right. Let's move over and let's talk about the calculation sheet here a minute. And what we see, we have the machine laid out. You got the sight machine, and you got the stationary or target and stationary machine, however you want to identify them. So in the process, we take a temperature gun, and as Dina said, we want to get 4 calculations, if we can, from the center line of the shaft down to the rigid base. And then do exactly what the sheet says in each of the columns, and it says we would add them up, divide by 4 to get an average. That's an average temperature.
Absolutely.
Average hot temperature. Then we got ambient temperature. You see the cold boxes there right adjacent to that. And again, that would either be checking it when the machine was down or ambient temperature around the room. And the differential comes from hot minus the cold, so that's our differential. And then you come down and then you see there where you put that in. Now, you see that box, it's going to be important that we put the plus or minus in there, because we could be working on a chiller or something of that nature. So we know exactly which way it's going. And then it's pretty much, we just follow the sheet. It says the differential or the average temperature change times the height. And then we multiply it by the coefficient of expansion. And then at the bottom, that gives us our thermal growth. And what we would come up with is a growth in mils, which we return and change that to thousands, in the planes of each feet. Now, and I don't think we would ever want to go out and do this unless we check all 4 feet. And then we make a determination at that point, is thermal growth an issue? And if it is, what do we do to correct it?